session. So we usually don't record our session, but because your review might be slightly different from the morning review, I wanted to give both classes the opportunity to see what each other asked. And if anything came up that was different, at least have the opportunity to talk about it and read it. So before we get into the review itself, let's just go through a couple of announcements. It's a busy week for us. We've got some post lectures this week. We've got some homework assignments this week. We've got quizzes this week. And we're rolling all of that up to prepare for our first exam next Monday during this time. So what's immediately due? Well, immediately due, we have the periodic trends post lecture that is due tonight in Smart Work. I didn't receive any questions over the weekend regarding the supplemental lecture. I also noticed that of the 60 of you in this class, there were only 27 views on YouTube, so I also know that most of you haven't watched it yet. So hopefully that kind of gets cleared up. We'll kind of take it as it comes. But that post lecture is due tonight in Smart Work. In addition to that post lecture for Wednesday, there is a pre-lecture. We are going to be doing chapter 4 this week, and a good chunk of our discussion on Wednesday is going to be talking about bonding, first and foremost, but also getting into talking about covalent bonding and ionic bonding specifically, and Lewis dots are a big part of that. So the chapter 4 folder has that first assignment in it, and that first assignment is going to be about Lewis dots, and that is due in grade scope tomorrow night. The other big thing due tomorrow night, you've got your homework and your quiz for chapter 3, both due in their respective places. Chapter 3 homework is in Smart Work. The chapter 3 quiz is in Blackboard. Again, both assignments due at the same time, both due tomorrow night at midnight. My suggestion would be obviously to make sure that you have the homework done before you take the quiz, instead of trying to complete both together. So if you can, carve out some time this morning or this evening and work on finishing that chapter 3 homework, and then use the results of that homework to help you with the quiz. The last thing I wanted to make mention of today is our first exam being next Monday. Wanted to kind of set out some of the parameters of what that exam looks like so that you can start preparing for it. And so to that end, there will be no Zoom lecture next week. I'm giving you the time on Monday of next week, class time, to actually work on the exam. So what I would do is, as far as the parameters are concerned, it is a take-home exam. There is no time limit on the exam, so you can open it at any time. You can download it at any time. The only parameter, so to speak, is that it has to be submitted into Gradescope by 10 p.m. And there will be no late submissions accepted for it. So make sure that you give yourself plenty of time to do it, especially, with multiple choice and everything. There will probably be close to 20, 25 questions on this thing. If you are submitting images, if you're taking a picture of each question, which I would not recommend doing, but if that is how you plan on doing it, you need to give yourself time to upload all of those questions. So take that into consideration as you are planning out your evening, and make sure that you give yourself enough time to do it. As far as resources are concerned, you're allowed to use your periodic table. You can use your equation sheet. In fact, I would recommend both of those strongly. Make sure that you have them when you're trying to work on the exam itself. What you can't do, you can't work together. You can't share information with each other. You certainly can't, do the work for someone else. And I strongly discourage you from using online resources to find the answers. While it is true that I cannot check you on those things, we are going kind of on the honor code here. And there are certain safeguards that I've put into the grading scheme to try to deter you, or at least make sure that, if you did look up the answer, that you have some way of showing me that you actually know how to do it and you didn't just look up the answer. So especially in the calculation section, correct answers are only worth part of the credit in the calculation section. There is a whole big chunk of the grade that is actually associated with showing me the work, showing me the process, and that you know how to do it. So if you give me the correct answer for a 10-point problem, for example, that might be only 2 or 3 of the points. The other 7 points would be from the process. How did you arrive at the answer? What steps did you undertake? If you did a conversion, what conversion did you do? What steps did you take to do that? Simply having the correct answer is not going to be good enough. You're going to need to show the hows and the whys. So best course of action for the exam, if you were able to, the easiest way to do it would be to print the exam off and write all of your answers on the exam, upload it into Gradescope as a PDF using Genius Scan or Apple Notes or some other kind of app that does the conversion to PDF. That's the easiest way to do it. All you have to do after you upload it as a PDF is just select the questions. Say, okay, questions 1, 2, and 3 are on this page. Questions 3, 4, and 5 are on this page, and so on. If you can't do that, you don't have a printer, you don't have access to one, the alternate way is to create an answer sheet. Just take a piece of notebook paper, piece of computer paper, whatever you got on hand, and then just write out, okay, number 1, multiple choice, answer was B. Number 2, multiple choice, the answer was A. Number 3, multiple choice, the answer was D. Number 15 in the free response question, here's my essay. And you just write out what the answer is. Number 17 in the calculation section, here's how to convert the density into a mass if I know the volume, or whatever the question is. And just, do all of it on a separate piece of paper, take your images however you want to do it, and upload it that way. Obviously one of those is a better alternative than the others just because the formatting will work out better for you in terms of how to upload it into Gradescope with as few issues as possible. But if you don't have access to that, we've done the answer sheet thing in the past. It works pretty well. Any questions about any of these announcements? All right, then. Let's talk about the Chapter 3 quiz. First of all, just like your other quizzes have been, it is remote proctored using Proctorio. Now, some of the settings in Proctorio are a little bit different than in some of your previous. You will be allowed to download from links that are in the quiz. So I've embedded a periodic table, I've embedded the equation sheet into the exam or the quiz instructions themselves. So you can download those directly from there and it will not block your access. You'll need to be able to take a picture and upload an image for one of the questions. So make sure that you have that capability. And so again, I've relaxed some of the Proctorio requirements to allow you to do that. So one of the questions is going to require you to draw an atomic orbital of a particular sublevel that I designate. So you're not going to be able to do that on screen. Blackboard has no drawing tools within it. But what you'll be able to do is draw it on a piece of paper and then upload that image. So take a picture of it, email it to yourself or however to get it into the Blackboard site. It's actually really easy to do. And with the relaxed restrictions in Proctorio, we will be able to do that pretty easily. So I know with some of the other ones, if you try to open up another window, it kick you out of the quiz or something like that. That won't be the case this time because for this quiz and for the next couple of quizzes, it's going to be harder to do the remote proctoring the way that we have. So some of the restrictions are going to be a little bit more relaxed to accommodate that, while at the same time, what we will do also is the screen recording will continue so that we can make sure that everybody's still kind of on the up and up. So those are the first three kind of parameters regarding the quiz and the quiz construction itself. There are 6 questions in total on the quiz. Important things to know. None of them are calculation based. So those equations that we used at the beginning of the chapter, the Rydberg equation, the energy, the Planck equation, the speed of light equation, those equations that were detailing the relationships between wavelength and frequency and energy and wave number of electron transition. None of those are going to be in this quiz. This quiz is a concept-based quiz. Now, that's not to say you will find a question like this somewhere on exam 1 next Monday. But in this spot for chapter 3, it's not going to be one of the things that we feature. There will be one question on the concepts of quantization, the Bohr model, the quantum mechanical model of the atom, etc. These can be things like, explain quantization, explain the Bohr model, explain the quantum mechanical model, or they could be things like, what is the difference between the quantum mechanical model and the Bohr model? How does quantization impact our understanding of the Bohr model? So they could be standalone definition kinds of questions. They could also be integration questions where we talk about how one model affects the others. So you need to have a good understanding of what those concepts are and how they ultimately fit together to bring us to our current understanding of the periodic table, our current understanding of the atom. There will be one question on quantum numbers and their corresponding orbitals or sublevels. So you need to have some familiarity with quantum numbers in terms of what do they tell us about the orbital and the sublevel in which an electron rests. We are not going to go as far as, here's a set of quantum numbers, what electron does it represent? We're not going to go that far, but kind of on the surface level, can you understand what a quantum number tells us, or what a series of quantum numbers tells us? There will be two questions on electron configurations. Really important note in here. Some of the questions ask for complete configurations. Some ask for noble gas configurations. Pay attention. If you give the wrong kind of configuration, I won't deduct all of the points, but I will deduct some points because you didn't follow the directions. So if it asks for a complete configuration and you give me the noble gas, you're probably only going to get about half credit if you're correct. If you're not correct, then you won't even get the half. You get 0. And then lastly, 2 questions on periodic trends. And a quick note about those. Again, this is part of the supplemental. If you're explaining periodic trends, so if I give you a question, which one has a greater radius, krypton or xenon? The correct answer is xenon. The correct response is xenon is larger because it contains more energy levels. The correct answer is not xenon is larger because it is lower on the periodic table. If you give an explanation based solely on the position of the periodic table, this one is below this one is to the right of this one, then you don't understand the trend. All you understand is positioning. You need to understand why the trend exists, not just that the trend is there. And so again, those questions are going to be, multiple part in terms of their grading. You need to not only have the correct answer, you need to have the correct explanation. And if you are missing one of those, then you're going to be missing part of the credit as well. You won't get the full amount of points. So those are the 6 questions on the Chapter 3 quiz. Again, should be relatively straightforward. You have 35 minutes to do the quiz. That's longer than the usual. And part of that is because doing the drawing on the paper and uploading it is going to take a little bit more time. But since there are no calculation questions, all of these questions are short answer essays, then you should have plenty of time to do everything that you need to do for this quiz and in that 35-minute time span. So any questions about the format of the quiz, the structure of the quiz, before we get into our actual review?
Could you go over the trends real quick, just as a review of what they specifically are?
Okay, so in the video that I assigned over the weekend, there were 4 trends that were discussed. The ones that you're going to be responsible for the quiz are atomic size, ionic size, and ionization energy. Now, to go through each of them in full would take about half of an hour, which that's why I made that a supplemental instead of doing that here. I would think that our time is probably best spent reviewing other things, because I know a number of you have questions about quantum numbers and configurations. But in terms of atomic size, let me pull up. Okay, give me just 1 second here. I've got to pull up a periodic table that I thought I had, but I don't. All right, here we go. So the brief 5-minute version is this. For atomic size, we see an increase as you go down a column, decrease as you go across a period. So my increase directions are down and to the left. So the largest atom that we know of is francium. Now, the reasons why have to do a lot with energy levels and something called effective nuclear charge. And again, I'll kick you to the video to learn more about those 2 concepts, because a good explanation of effective nuclear charge takes more than a couple of minutes to do. So for atomic size, again, as you go from left to right, it gets smaller. As you go from top to bottom, it gets bigger. For ionic size, if charges are the same and in same column, then they follow atomic trend. That's not usually what we're talking about with ionic size, though. We're usually comparing cations versus atoms, anions versus atoms, and isoelectronic series. So if I'm comparing lithium, the atom, versus lithium plus the ion, Well, based on what we saw in our electron configurations, lithium has electrons here in the second energy level. Lithium plus has the electron configuration of helium, so it does not have electrons in the second level. Lithium atom is going to be larger. If I compare anions to their atoms, the trend is reversed. If I'm comparing sulfur to sulfide, sulfur and sulfide have the same number of protons in the nucleus, but sulfide has 2 extra electrons. The extra electrons yield greater repulsion, and that's going to push the atom, or excuse me, push the ion to be larger. So atoms were larger for cations versus atoms. Anions are larger for that trend. In an isoelectronic series, all the species have the same number of electrons. So if I were comparing, say, a whole bunch of things that had the same configuration as argon. So I was comparing sulfide ion and chloride ion. And argon and the potassium ion and the calcium ion. All 5 of those ions would have 18 electrons. Which one would be the biggest? Which one would be the smallest? The trend there, size decreases with the number of protons in the nucleus. So the smallest would be the calcium, the next smallest would be the potassium ion, argon would be the next smallest, chlorine would be the next smallest, sulfide would be the largest. The last trend, again in brief here, ionization energy. It largely mirrors atomic size, but in reverse. Small atoms have large ionization energy. Large atoms have smaller ionization energy. There are some exceptions. Group 2 versus group 13, and group 15 versus group 16. And these are all configuration based. So again, from a comparative standpoint, if you have a pretty good handle on atomic size, you have a pretty good handle on ionization energy as well. It's just kind of the flip, it's the reverse. But there are a couple of exceptions in there. And again, the discussion, I'm trying to give you the flyover view here. The if you haven't watched the YouTube video that I made on Friday for that topic, you really need to. You're going to get a much greater detailed explanation than this flyover view. This flyover view will be helpful in getting the right answer, but it won't be as helpful in getting the right explanation. The explanations are in that video. But this at least gets you a head start. All right, other questions, other things that we want to talk about. We've got about 20 more minutes that we can review.
To upload the drawing picture, do we do it during the quiz or after?
During. Yes, you'll do that during the quiz. So the way it'll look is, let me come over to my Blackboard page here. I can show you. I can't show you the quiz that you're going to take because I've already proctorioed that up, and so I can't preview any quiz that's already been embedded into Proctorio. But I can show you one that is similar. And so the similar quiz right here. So if you look at question 6 on my screen here, it says, on a separate piece of paper, draw the Lewis structure for PF4 plus. Take a picture and upload it here. Only hand-drawn submissions will be accepted. Okay, this is the quiz for chapter 4. Obviously, you don't know how to do all of this yet, but the way that the question will appear is the same. It'll be a question like this. It'll say attach file, and it'll give you an option to browse your computer and do it. And so all you need to do is, like I said, make the drawing and then either take a picture of it on your phone and email it to yourself so that you can grab it off of the screen through your email, or do some other kind of capture in that kind of way. So either use a screen capture service using your webcam or something along those lines to allow you to take that picture of that object and upload it into the quiz. And like I said, I've relaxed a lot of the Proctorio settings so that you should be allowed to do that. And again, if it comes up that that's a problem, then I will give everybody a heads up and say, okay, this isn't working. This is what we're doing to get around it. So if it comes to be a big problem, we'll adjust on the fly. But I believe that I've adjusted the Proctorio settings appropriately to allow you to do this question and not have any issues. And part of the reason that you're getting a little bit of extra time is to allow you the time of doing the question, taking the picture, uploading it to your computer, uploading it into the quiz. All right, other questions?
If we were to have trouble, just for just some crazy reason, like maybe the email wouldn't send or just something, what would you like us to do?
Notify me.
Okay.
Notify me, send me the picture that you're trying to email, and I can always work it into the grading.
Okay, thanks.
Okay. other questions, things that we're stuck on?
Can you do an example of the configurations for the ions that we did Friday?
Okay. All right, so let's go back to our periodic table. So, Taylor, did you have a particular one in mind, or?
No, just any of them to get the general idea again in my head.
Okay. All right, so just as a matter of clarification, I'm gonna go ahead and draw back in our blocks just so that we have the visual. So I've got the S block over there. I've got the P block over here. I've got the D block right there. And I've got the F block down here. Now, one of the ones I know gave a lot of people a little bit of trouble was the gallium. The gallium configuration, for example, if I was doing gallium metal would be argon 4s2 3d10 4p1. That would be the configuration for gallium metal. Now, in the example, I asked you for gallium 3+. And the configuration for gallium 3+, remember, when we are doing electron configurations that involve d electrons or f electrons, we always have to take from the highest energy level possible. So if I'm losing 3 electrons in total, I'm going to take this one from the 4p. It's the highest energy one anyway. But I'm going to skip over the 3D. Why am I skipping over the 3D? Because between the two, the 4s and the 3D, there's a gap there. There's an energy level gap. And even though the 3D are technically higher in energy, the 4s are further from the nucleus and therefore easier to remove. So these 3D gets left alone. I'm going to take these two as well. End result, argon 3d10 is my configuration for gallium-3 ion, as opposed to argon 4s2 3d8, which is, I know, a number of you came up with as your answer.
Are we ever going to have to like reverse it, like start with the AR 3D10 and go back to the original?
So what do you mean? So if you gave me argon 3d10 4s2 4p1.
No, like if on a quiz you just had the argon 3D10 and you wanted us to go back to how we got there, so the answer would be the AR4S2 3D10 4P1.
So
like backwards.
So you don't have to show me that process. You don't have to show me that process. That one is results oriented. But at the same time, you do need to understand, why is it that we took those electrons away? Why were these electrons easier to take than these ones? So again, it's going to kind of go into that, simply knowing the correct answer may not be good enough on the exam. Now tomorrow I'm just looking for the nuts and bolts. I'm looking for, the correct answers. We're not getting too deep into the explanations other than the periodic trends or that essay question I talked to you about with the quantization and the Bohr model and whatnot. I mean, as far as the configurations are concerned, if you had given me, if you gave me 4s2 3d10 4p1 or 3d10 4s2 4p1, I'd consider either one of them correct for the configuration of gallium. For gallium-3, for the gallium ion, it has to be this. This is the only possible configuration, argon 3d10. All right, let's do one more example out of here. Let's do the complete configuration of silver and then of silver ion. So the complete configuration of silver, starting from the top. So let me put a dot here of some kind on my silver so I know where I'm ending. Starting at the top, we would have 1s2, then 2s2, then 2p6, then 3s2, then 3p6, then 4s2, then 3d10, then 4p6, then 5s2, and now we're getting into the configuration 4D, that's where silver is. And we go, okay, that's 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, at that configuration, immediately we should be thinking in our head, wait a second. D9 configurations were one of the ones that we targeted on Friday and said, we don't ever see D9. So that should immediately trigger, hey, this is an exception. And the exception is an S1 exception where one electron moves from the S to the D to give us 4D10 there. Now for the silver ion, again, we have a +1 charge here. Where does that +1 come from? Where do we lose an electron? We lose an electron from the electron that is furthest away. The furthest away electron is that 1 5s electron. So in terms of its configuration, it's exactly the same. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 4d10. 5s1 goes away. Now, based on this configuration, you should be able to kind of rationalize, oh, hey, you know what? It makes sense why silver only has one oxidation state, why we never have to call it silver 1. It's always just silver ion because it's always +1. Because look what happens when I remove that 1 electron. I've got a full first energy level, a full second energy level, a full third energy level, and Well, not a full fourth energy level because the 4f is still empty, but all of the sublevels that have electrons in them in the fourth energy level all have electrons. They're all completely full. So there's nothing that's empty. There's nothing unfulfilled. And so when we get into the look of, okay, why does zinc never form anything but a +2? Why is cadmium always +2? Why is gallium always +3? Why is indium always +3? You know, when we start looking at it from that perspective, why is gold usually +1 and nothing else? We can start to rationalize, okay, this is why. Look at the configuration after it loses that electron. It's pretty stable. It doesn't need to do anything else. All right, we've got time for probably one more question.
Can you do an example with a negative charge,
Okay.
like the I negative?
Okay. Now, the wonderful thing about negative charges is that they're always nonmetals. And so because they're always nonmetals that do this, all that we have to do is move over. So the negative charges usually come from elements in this, bracket of zones here. So these 11 elements, occasionally hydrogen. But the thing is, when they do, the elements that they yield are all noble gases. So if I'm doing a noble gas configuration of an anion, I'm going to end up with just a noble gas. So you mentioned iodine specifically. Now for iodine, we'll go noble gas configuration here just because iodine's got quite a few electrons. Noble gas configuration for iodine, the nonmetal atom, is krypton 5s2 4d10 5p5. If I'm dealing with iodide, that's I minus, one extra electron. Well, that one extra electron would go into the 5p. We could write this as either krypton 5s2 4d10 5p6. But that configuration belongs to a noble gas. That noble gas happens to be xenon. And so the noble gas configuration for the iodide ion, I minus, would just be xenon. Technically, yeah, you could do the one with the krypton on the left there, but I mean, that matches the configuration of xenon perfectly. So the ones that are tricky really are the cations, because with the cations, especially once we get into the lower levels of the periodic table, we have to start thinking about how those d electrons get impacted. But for the anions always end up on a noble gas. And so if we're asked to do the complete configuration, we just give the complete configuration of that noble gas. If we are doing a noble gas configuration, then we just bracket the noble gas that it ends at. So they tend to be a lot easier. All right, that puts us right at time. It's 10 to 1 right now. I don't want to keep anybody from getting to their 1 o'clock classes on time. So we'll stop it right here. If you have some questions, I do have a few extra minutes. I can hang around and answer them individually. But anyone that's got somewhere else to be, go ahead and go. This will be up on YouTube within the hour. If you want to review anything that we looked at, or if you want to look at the morning session, we did talk about some slightly different things. They had some questions about quantization and some of that first essay question. So that might be a good watch right there for you. Probably skip ahead to about the midway point for that. Have a good afternoon.